Bismillahirrahmanirrahim. This video will be discussing two questions from GATE exam 2023, which is used for the entrance test. Okay, so the first question that we'll be discussing is question number 29. And the value of the parameters of the circuit is shown in figure. So these are the values that I have already written here. For t less than 0, the circuit is at steady state with the switch K closed condition. So this is closed and the circuit is in steady state. Steady state means it is there for a long time, and therefore in a steady state, the inductor will behave like a short circuit and the capacitor will behave like an open circuit. So you have to keep this point in mind. Now, if the switch is open at t is equal to 0, so t is equal to 0, this is open. The value of the voltage across the inductor at t0 plus is so many volts that we have to find. Okay, so keep in mind that we have to find VL0 plus. But let's start with 0 minus. T is equal to 0 minus. The switch is closed. And as I mentioned, the inductor will become short circuit or behave like a short circuit, and the capacitor will behave like an open circuit. And now you can see this current has two paths. One is going through this and the other is going right. And the right hand side, the lower portion is open, so no current will flow here. So this current I2 will only flow through the upper portion. Okay, so first of all, we need to find I2 by CDR, current division rule. I2, we will call it I2 0 minus because we are at T 0 minus. So this will be the total current 10 divided by total resistance. So this is one resistance 3 and this is another resistance 2. So total resistance is 5 multiplied by opposite arm. So we want to find current in this. Therefore, we have to find or use the resistance of the opposite arm, which is 3. And that means IL0 will be 6 ampere. So this we have noted down, 6 ampere. And then, since we know this current, we can find the voltage here. We are calling it V10 or V0 minus. And this will be simply I into R. So V0 minus is I into R, or IL0 into 2, which is 6 into 2, which is 12 volt. That means this voltage here is 12 volt. Now from here we have to find this voltage. And let me separately show it. If there is a battery of 12 volt and we have a resistance R and a capacitor C, then this capacitor will charge to how many volt, how much? Now, some student might get confused that because of the resistance there will be voltage drop, but that's not correct. The capacitor will ultimately charge to the full battery voltage. That means this will be charged to 12 volt. So with same logic, this voltage VC 0 minus will also be 12 volt. Okay, so we have found the two parameters which were at T0 minus. And then we move to T0 plus. So at T0 plus, this switch is open. That means there is no current flowing in here. So all this current will flow through the two branches. And since at T0, the circuit will now be in the transient state, or will be moving to transient state, therefore, I have not shown it to be short and open. And a very important point, actually, which is emphasizing or which has very importance in the solving of this question, that is the two characteristics that the inductor current and the capacitor voltage does not change instantly. That means if this is 0, slightly before is 0 minus, and slightly after is 0 plus. So whatever is the inductor current or the capacitor voltage at this point, that is at 0 minus, it will remain same at 0 plus. It will not change instantaneously. Gradually, it will obviously change, but at this point, it will remain same. So from here, we can write that IL0 plus is actually equal to IL0 minus is equal to 6 ampere. And similarly, VC0 plus will be VC0 minus, which was 12 volt. So these two, 40 greater than 0, we have found. And now we put in the circuit. Now this, initially we had written it IL0 minus, now we're writing it IL0 plus. And similarly, this voltage is now VC0 plus 12 volt. Now 10 ampere is the current entering, 6 going towards this side, therefore 4 will come down. So I1, I'm calling it I1, I1 will be 10 minus 6, that is 4 ampere. And let's mark the polarities because we'll be solving this KVL equation in this loop. And we know that wherever current enters, that terminal becomes positive. So this positive, similarly this positive, because of this current, positive here and positive here. Okay, now with this sign convention, let's write the KVL equation in the loop. We can start from anywhere. I'm starting from here. So this is I into R, that is 2, 6 into 2, plus sign, then plus VL, then coming here, minus sign, so minus 12 for VC, so minus 12, and minus I1 into R2, that is 4 into 2. And from here we can find VL to be 8, actually minus 12, then plus 12, and plus 8, which is equal to 8 volts. Now this is VL positive that we are looking for. Now there's another question that we'll be solving, that is question number 32. For the circuit shown in figure, V1 is 8 volt DC and I1 is 8 ampere DC, and the voltage AB we have to find out. Now, I'm sure those who are preparing for the exam, they must look for the short circuit methods, shortcut method. But first of all, immediately in at least my mind, it came that, okay, if there is a voltage source and there is a current source, then we can use the superposition theorem. So many of you might think on that line. So let's see what is the effect of this. So if you can't think of a shortcut method, let's try the long way, that is the superposition method. Considering voltage source only, so the current source will be 0, and current source is 0 is when we cut it off. So this will become the circuit. And from here, couple of things. One is, you can see this whole comes in parallel with this. So this one is coming in parallel. But this is, there is a short circuit. So all current will go through here and no current will flow through this. Therefore, this becomes redundant. And so our new circuit will be like this. And from here we can find VAB. Let's go to the next page. I'm calling it VAB dash because of one source, V1. Now these two are in parallel, you can see. So solving, it will become 1.5, 3 parallel 3, 1.5 ohm. And now we can easily apply VDR to find the voltage VAB dash. VAB dash is 8 divided by these two resistance multiplied by 1.5, so 6 volt. Now we consider the current source. For current source, then we have to put voltage source 0. That means, and voltage source is made 0 by short circuiting. So the circuit will become like this. And from here you can see that this current is only flowing through this path. It will not go to the right side. That means there will be no voltage drop here, 0 voltage drop. Since no current flows through AB terminal, hence VAB double dash is equal to 0. And adding the two, we can find VAB, which is 6 plus 0 is 6 volt. So this is the long way. Let's see if we can find a short way. And the short way is straight away we draw this short circuit line here. And then you can see from here, this point and this B is in parallel, because now this point B and this is same point. Therefore, these two are in parallel, and two in parallel will become 1. Remember, we have to find this voltage, and let's redraw this circuit like this. So this is the current arm, voltage, and the right arm. Now I hope you know that whatever is the voltage here, which is 8 volt, will be same here, 8 volt will be same here, 8 volt. So using this logic, by voltage division rule, we can directly find the voltage VAB. So VAB is 8 volt divided by 0.5 plus 1.5 multiplied by 1.5 is equal to 6 volts. So this is, I hope, is comparatively easier to follow. I hope you have been able to understand the techniques. Please let me know through your feedback. Thank you.